Assalamualaikum, my name is Muhammad Khairul Nazmi bin Azman. I'm from RK86. My metric number is 181032823. Okay, today I will present about MEMS Capacitive Actuator. An actuator is a component or device or machine that convert energy such as electricity, air, or hydraulic pressure into a mechanical force. The operating principle of the design, MEMS capacitive pressure sensor is based on the deflection mechanism of the membrane using parallel plate capacitive. Okay, this is the formula that we use, which is capacitance equation. Okay, the capacitance equation is help to calculate the change of the capacitance and sensitivity input pressure. And for the sensitivity equation, it's help to calculate the capacitance over the deviation of the input pressure.
You can see that the left hand side it is actually our overall layout view, and for the layout we actually have 16 layers, but the main material that we use are aluminum alloy, copper alloy, silicon substrate, and silicon dioxide. And those materials we have defined it, and the coordinate XY are set at the origin, and the width and the length of the layers are defined in micrometers. And due to the complexities of the layout is not able to show at once, so for more details layer layouts we will be presented in the process definition and 3D model section. And you can see that over the right bottom, here's the tables that show about the material database that we use to build our project.
Sir, madam, good day. My name is Cho Shishan. Currently, I would like to talk about the MEMS fabrication simulation. For the process definition of this project, we consist of 16 different processes, and there are 2 processes that is dedicated to wafer bonding. The blue color is the silicon substrate, red color is the silicon dioxide, the yellow color is the copper alloy, and the gray color is the aluminum alloy. The first wafer bonding occurs between step 2 and 3 wafer, which produce a wafer at step 4 here, which is the SOI, silicon on insulator wafer. The next is the combination between step 10 and step 13, which will produce the wafer we saw at step 14. So the aluminiums and the copper on top of the design, as we can see from the final 3D model up here, is the electrical property of this MEMS design. So the aluminium acts as the electrode, the gray color, and the yellow color is the copper wiring of this design. So from the cross section here, we can see that the electrodes will allow the movement of this silicon within the design. That's it from me. Thank you.
Hi, I will explain the finite element analysis part by using ANSYS system for this project. We're using static structural system for the material declare, geometry input, and boundary condition simulation. Beside the analysis system is our geometry design, which the left one is in the space plan and the other is in the mechanical. And the row 2 shows the model and our analysis with solution test. Then is our mesh and also the input and boundary condition. For the east to see what the content inside, there is a cross-section view for the mesh and condition. For the input and boundary condition, we make a fixed support on side of outer layer of the actuator and giving a pressure on the flexible point of the actuator shown in the diagram. This result is based on the analysis of the pressure magnitude and the normal elastic. From the left top figure, the pressure is fixed at the silicon surface on the flexible part of silicon. With the simulation done, the pressure is pushed onto the flexible point of silicon, and the left bottom is presenting the simulation using ANSYS. When an electric power is connected to the actuator, the part will move to measure the displacement. From the result of 10, it can be concluded that when the elastic strength value will be decreased as the pressure increase. That is this analysis, the pressure magnitude has an inverse linear relationship with normal elastic.
In terms of campus sustainability, this actuator has shown its function in field different management. There are 2 main management being focused in this project, that are light management and flood management. Before go to the application of actuator in those fields, there are some issues might occur in campus area. In terms of light management, some area might not have enough light source during nighttime, and this will endanger the safety of students. Moreover, if the light poles are meant to turn on at night for hours, this will also cause the high cost in electricity tariff. While in flood management, some areas will experiencing flooding situation after a heavy rain, and these problems will arouse the normal daily activities on the road. With the application of actuator, the smart lamppost can be designed in light management. It will be automated, meaning if it senses an object and then it will automatically turn on. Otherwise, it will not. Energy consumption will definitely become lesser, and at the same time, the electricity tariff will not increase as well. As in the third situation, a device built with the actuator can be placed at the sewage area for water level sensing purpose to prevent any unfortunate. Back to the principle of actuators, usually a device is operated based on the development of both sensors and actuators, and therefore when a sensor is used to collect data, the actuator will be supplied with certain amount of voltage afterwards. Then the actuators will be given out the output according to the particular field of needs.